Hello everyone and welcome back to another episode of the Hidden Quantum Champions. Today we are looking into a company called QBird that is working on quantum communication, so secure quantum connectivity. And if you want to learn more about this company and what is the differentiator against other companies in the market, then stay tuned for today's video as we are diving deep into QBird. And as per usual, get yourself something to drink. This video is going to take a couple of minutes. Get yourself comfortable. And with that, let's start right into it. So here we are on the website. It says QBird Quantum Connectivity, Secure Quantum Connectivity, Building a Scalable Quantum Infrastructure. Now a little bit of a step back quickly for the people who are new to quantum connectivity or, quantum communication. What is the idea? Well, with today's quantum computers, we cannot yet crack the encryption that is being used. But in the future, quantum computers might be able to actually break existing encryption mechanisms, which are based on factorization of prime numbers. Now, the way that you can already basically today cause harm with that is by something that is called harvest now, decrypt later. So you basically listen into somebody's conversation, which is encrypted. You are storing all that data and you keep it until one day you have a quantum computer that can break it. So how can we avoid this? Well, there's actually a way to do that, which is by producing a key that is about the same length as the message and making sure that this key is only being shared between specific parties. And this is something where quantum technology can help, or where quantum physics can help, because quantum information cannot be cloned, so you cannot copy it. There's a non-cloning theorem, so you cannot just sniff in between and copy the information. But actually, if the two parties that are using this quantum communication channel, they are able to realize that somebody has been listening in, and that's actually, let's say, the main idea of this whole quantum encryption. Now, with that said, let's look into what they're actually doing and how they are building a scalable quantum infrastructure, which is actually something that is also tightly bound to the unique selling proposition of QBird. So we build devices for quantum secure data communication. QBird offers hardware and software solution providing ultra-secure data communication and protection of critical infrastructure based on the laws of physics. That's basically what I said. That's not something that is just unique to them. There are actually also other providers in this quantum communication space. And if you want to know which ones are out there, then I encourage you to go onto the YouTube channel after you watched, of course, this video, and to check our playlist, which is called Hidden Quantum Champions, where I list all of the more than 100 companies that in the meantime I've been reviewing, and some of them are also from the space of quantum communication. But now back to QBird. So what are the products? They are offering the Falcon, of course, with a Q4000 series. So Falcon 4000 series integrates seamlessly with telecom and data communications. Quantum Domain Controller is the other one, QDC. The QBird Quantum Domain Controller is a web-based platform for centralized control, communication, management and monitoring of QBird Quantum Key Distribution Network. So that's basically the software and the hardware that are both being sold by QBird. So then we see here the key to quantum security, technology, quantum communication and quantum key distribution. Let's start with the key distribution. So quantum key distribution adds an entirely new layer of the IT security system, protecting an organization's digital infrastructure. Then quantum communication, because of its unique and groundbreaking features, it has the potential to completely transform information and communication technologies. And then, of course, their technology. Today, it's very important to be able to exchange information securely over the global internet. And there's also a brochure which you can download there. Then there are some news down here. The latest one is Ireland's Quantum Leap, Walton Institute at SETU and QBird deploy Ireland's first QKD network with expandable architecture. QBird, the Dutch leader in quantum secure communication, in collaboration with the Walton Institute at Southeast Technology University in Waterford, SETU, has deployed Ireland's first multi-node entanglement-based measurement device independent quantum key distribution MDI-QKD network. And that is, by the way, something that is very important. Measurement device independent is something that is, let's say, a sales point of QBird, something that they can do, which others can not necessarily do. There's also more news down here. I looked it up before, so the latest one, the one that I was just reading to you, is from, I think, March 2026, and I'm recording this in April 2026, so it's very much up to date. And then something else is worth mentioning. We saw already they position themselves as a Dutch leader. They are based in Delft, in the Delft Tech Park, which is a quantum hub. So multiple of the quantum companies within Europe are based in and around Delft. So probably a very good position also locally to be in. Now, let's quickly check on the technology side, because I think that's where things are getting interesting, and that's probably why you are also watching. Let's see what we have here. So quantum key distribution technology, MDI-QKD, quantum communication for modern digital connectivity. I think that just explains the ground concept of the, let's say, quantum key distribution. As global communication expands and security threats evolve, secure information exchange over the internet has become paramount. The answer is quantum secure networking powered by quantum key distribution. Measurement device independent quantum key distribution takes this a step further by removing the most vulnerable part of the traditional system, the detectors. It enables secure key exchange even if the measurement devices are compromised, making quantum network more secure and scalable. MDI-QKD is a major step towards forward in building secure, scalable, and trustworthy quantum communication networks, essential for the future of digital connectivity. Now, let's see. Do we learn something here about the measurement independent technology? Let me quickly check. Shaping the future, implement practical, yada, yada, yada. So there are some use cases also mentioned here: critical infrastructure, government and military communication, financial transaction, healthcare, and large organization and telecom, which is all something that we've also seen with competitors before, and which I would say makes sense as well. I think this is probably one of the most important parts of today's video in terms of technology, let's say. And that's how the quantum key distribution actually works. So you see here the network that they are proposing. You see the different, let's say, parties. So you see here the QKD nodes, the quantum key distribution nodes. Then you see these hubs over here, and you see your VPN. And now, how does all of that play together? What is interesting is you have the quantum key distribution node, and you have multiple of those, right? And they are connected to these hubs over here. And one hub, and that's something that is key over here, is actually connected to multiple of those nodes. So if you're looking at this hub over here, for example, it is connected to another hub, but then it's also connected to each single one of those nodes. So basically, each node is connected to each other node via this QBird hub over here. And that's something that is unique, because traditionally in, let's say, other cases that we've looked at before, you have usually two parties that are connected to each other via a specific line. So there's basically a single connection, and each party is connected by a unique connection to each other. Whereas here you have this kind of star shape of the network. Well, in this case, you have two stars, and they are all basically connected to every single node. And that's kind of what makes it unique, and how the whole system is probably also set up. So now I could imagine, but that's a guess, that this QKD node is actually what is distributing the quantum key, right? So it's producing the photons. And then you might have the detector sitting in the hub, so that you cannot compromise the detector easily, because it's basically locked up here in the hub. But maybe I'm also wrong with that. I don't know. Let's read through it and see if we can learn more about it. So our unique quantum key distribution technology offers the following benefits that set us apart from existing QKD solutions. Unparalleled scalability. Our QKD architecture allows for true multi-point to multi-point QKD. This means that a network can grow to hundreds or even thousands of users without a complete redesign or exponential increase in hardware required by systems using a separate link for each pair of communicating parties. That's what I said before, right? So otherwise you would have to have a separate communication channel for each basically commutation of two parties that you add to the system, right? Then enhanced security. So our system is immune to all known and yet to be exposed detector side channel attacks, which are identified as a significant vulnerability against existing QKD implementations, such by, for example, ETSI and BSI. Then you have the enhanced safeguard. So our center hub doesn't need to be trusted, eliminating the security weakness present in trusted node QKD networks. So probably there are no detectors then in the hub if you don't need to actually trust it. Then cost effectiveness. So by centralizing costly components, for example, single photon detectors in the central hub. Okay, so there are the detectors in the hub. We significantly reduce the cost per user as the network grows. Eliminating expensive quantum receivers at each node makes large-scale deployment economically viable compared to systems where each node requires full QKD capability. And then future proofing, so our technology based on BSM and patented quantum control systems aligns with the future of quantum networking applications, providing a clear upgrade path that many current QKD systems lack. So here's how it works. You have the physical layer with the central hub and then the different nodes around it. And the logical layers where basically every node is connected to every other node. And that's what you want to have in such a network. So QBird is the first to commercially offer equipment to implement a new secure type of quantum network. Such a network can connect multiple users through a center hub in a cost-effective and scalable way, which can provide a secure data connection between many users by users be protected against eavesdropping. So that's basically the physical layer. Eavesdropping on communication systems by malicious parties can lead to significant financial losses, disruption of critical business operations, or physical damage. Our quantum communication infrastructure guarantees a connection protected against eavesdropping and will further enhance the logistics chains of the vital infrastructure on the European continent. Our technology is based on a special implementation of quantum key distribution, QKD. This type of QKD uses a center hub to connect users who want to exchange secure communications. A user device will need a connection to just the center hub to establish a QKD key with any other end node in the network. This makes our QKD technology very sustainable for scaling up to many user network. Moreover, the user devices do not contain any quantum measurement devices, making the scalability of our QKD network also cost effective. And that's then because in here you probably have the single photon sources, whereas here you have the detectors in these central nodes. And then if you're looking at an end-to-end data transfer, you would have of course your data channel, which has an encryption in between. The key that is being used for this encryption is as long as the message, hence you cannot easily break it. And this key is being generated here on this second path, which is then, let's say, the quantum path of the network, where you have the two QKD nodes, MQT 4000, or I guess the Falcon 4000, and you have the center hub in the center between those, connecting those to each other. Okay. And of course, that is very important, the scalability of the network, because if you're looking at networks, like generally networks, like social networks, telephone networks, and so on, a network benefits from, let's say, the growth of the network. So if you think, for example, about messaging apps, Well, WhatsApp might not be the best messaging app, people might argue, but it's actually not so easy to establish another one, maybe based on a better or more private technology, because there's not so much benefit of a user to actually join this other network, because usually the people that you want to connect to, they might not be on it. So think about your social networks, right? In the past, like before there was Facebook and before there was Instagram, there were a lot of smaller social networks, but they basically all got killed or taken down at some point, because only the biggest network is the one that really at the end takes it all. It's a winner takes it all kind of market situation. And what QBird is doing here is they are strategically positioning themselves as the network technology that has the smallest cost of growth. Hence, the idea would be that, okay, by this you can probably scale the network cheaper than others, so you have a competitive advantage. And if the telecom providers understand that, they might have a higher likelihood to invest into this one here, because they pretty well understand that network basically, or growing a network is vital to the business, because otherwise usually you don't have many competing networks against each other on the same, let's say, field. Let's quickly check out the products. I think we've talked about them before. So there's the Falcon, and then of course there's the software side of it. Here we see different versions of the Falcon. So the MDI-QKD Falcon series. The Falcon series consists of 3 main elements: end node, quantum optical switch, and center hub. The end node we've seen before in the network. The center hub we've also seen, and now we also see that there's an optical switch added over here. Many end nodes can be connected to the center hub. Each pair of end nodes connected to the same center hub can generate QKD keys, which remain secret from all other devices in the network. Each end node, MQT4000s, is directly connected to the center hub via a pair of optical fibers and can generate quantum keys with any other end node in the network. Quantum optical switches, MQS4000s, can be placed around a network to form the optical fabric and transport qubits to their destination. Center hubs are present only to establish quantum connectivity between the end nodes, forming a multi-point to multi-point network between many end nodes and devices. So, a couple of things to take away from here. First thing is that I see here is a pair of optical fibers, so you need 2. That is different from other technologies that can, for example, also operate on a single optical fiber, as to my understanding. But of course, that has to do something with how the, let's say, geometry of this setup is being built, right? With the basically detectors being centralized in this hub. You might need 2 optical fibers then. Then you have the quantum optical switches. So they basically, as it says here, can be placed around the network to form the optical fabric and transport qubits to their destination. So they can basically be like routers within the network, as far as I understand. And then you can really reach this end-to-end encrypted communication. Secret QKD keys are never present in the center hub. The center hub never has access to any sensitive data. This is made possible by the next generation quantum protocols in QBird devices. And then here we see the different devices. So that's the MQT4000, so the node. Then we have the center hub over here, and we have the switches over here, or the mirror optical switch. On top of that, there's the software, right? The QBird Quantum Domain Controller, QDC, which is basically controlling the overall network. And then here again, there's an explanation of how the technology works that we've seen also before. Resources, just to quickly point out. So there's also blogs and press material over here, as well as the news section. We've seen that before. So this news is for March 2026. Then we also have from breakthrough to backbone, a defining moment for quantum secure communication. We, QBird, extend our heartiest congratulations to Charles Bennett and Gilad Bassar on receiving the ACM-AM Turing Award, often referred to as the Nobel Prize in Computing, and so on and so forth. So you see there's a lot of traction also in 2026 already here on QBird's news article side. Now let's quickly learn about the company itself, as we usually also do within those videos. So our story, QBird, is a Delft-based company founded in January 2022 by experts in quantum communication from QTech and TU Delft. With over 30 years of combined experience, our team has developed a unique MDI-QKD, so measurement device independent quantum key distribution product that leverages the fundamental laws of physics to ensure provable security even against future quantum computers. Our technology, extensively tested in collaboration with industry leaders like Cisco, Juniper, and Eurofiber, offers unmatched security and cost efficiency. QBird is proud to have secured a launching customer in the port of Rotterdam and has signed contracts to deploy quantum networks across Europe. QBird has extensive experience in creating and integrating these products with companies for commercial and industrial purposes. I guess here we see the founders. Then we see something about achievements and roadmap down here. So today we are building QKD devices for secure communication with quantum technology. This includes network communication devices for securely transferring data protected from even the most powerful computers, devices for sending qubits, hubs that generate entanglement, and networks that provide multi-point to multi-point connectivity. And all are intrinsically more secure than point-to-point based QKD solutions. Tomorrow, we will enable quantum connectivity between quantum devices to general quantum networking applications. The same technology as that of our hubs will be used to connect quantum processing nodes and quantum sensors. Our system will provide the basis for the quantum internet of the future. And that's something that I've been talking about also in previous videos already. So the quantum secure communication is of course interesting, and it is a good starting point, but eventually it will develop also into something like a broader quantum internet where you have quantum computers that can exchange quantum information with each other. Not necessarily computers also of the same type, right? You might have a supercomputing qubit on the one side, and you might have a ion on the other side, or a neutral atom on the other side. And you might have those systems exchange information, because then you can actually spread also quantum algorithms across different machines and have parts of the algorithm being executed where it's executed most efficiently, and then kind of put everything back together to get, let's say, an overall better performance. That of course requires a lot of bandwidth. But then you can also have quantum sensors connect to this network as well. And here I have to say I never fully thought this through. I think on a top level it makes sense. But what is probably a bit harder to understand is there some quantum information that is, let's say, at the end not digital as in 0 or 1, but really like in a superposition that you can, let's say, measure in the real world and meaningfully, operate on a quantum computer, like simulate or basically work based on a quantum computer. But that's maybe something for a future video. If you wanna, let's say, talk about that, let me know down in the comments below. I'm always happy about new ideas also to move on with this channel into, let's say, new formats. Now let's quickly look into the roadmap and achievements. So pilot prototype in real world was achieved in Q2 of 2021 with KPN and Cisco, and has been deployed between 3 cities. Then also in 2021, end of 2021, demonstration of hybrid fiber and free space links. Free space means basically no fiber, but probably within, maybe in the space, but maybe sometimes that also refers to ground to space or something like that. And then ABN AMRO used our system to secure financial transaction for weeks. Then a demonstrated testbed and data center launched with Eurofiber and Juniper. Then Lighthouse customer for QBird products. So that's Rotterdam, which we've seen before, which got basically signed in 2022 and then deployed in 2024. In 2025, so last year, deployment of the first cross-border MDI-QKD link in Benelux. And then, the next one is going to be 2025 to 2026. And I mean, we've seen what they're also aiming for in the future. Then a couple of collaborations and partners listed down here, like TU Delft and Cisco, we've seen before. Euro QCI, I think, is also important. Then SI is, I think, a single photon, looks like a single photon detector to me, so might be a partnership with a single photon detector company. I think they are also part of this European Quantum Internet Consortium. I have, maybe that's Euro QCI, Quantum Communication. No, not sure, but I think they're also part of this. So and there are many other collaborations. For example, don't wanna go into this for now. But okay, I mean, that's probably everything to talk about in today's video. I hope you found it interesting. So QBird, company based in Delft that is working on quantum communication solutions. They have figured out a way to make networks scalable in a cheaper fashion, which I think is their USP and gonna help, let's say, the company to grow and to expand their operations even further. I'm interested, of course, in your opinion, so let me know down in the comments below. And if you don't want to miss out on the next video, make sure to subscribe. I'm looking forward to see you again in the next one. Until then, bye bye.